Okay, welcome back everyone. This is the backside of Integrated Math 2, Practice 4, where we're solving quadratic equations. On the back I've given you 6 that I want to solve by factoring and 3 to solve by the quadratic formula. So starting with number 1, if we want to solve by factoring, set it equal to 0. Open up your 2 parentheses whenever you have one of these quadratic trinomials, 1, 2, 3 terms. Starting with that x squared, that had to have been x times x to make x squared. What could have made a 16? 1 times 16 is 16, but so is 2 times 8, and so is 4 times 4. Which of these sets of factors also give me a 10 by adding or subtracting? That would be 2 and 8, because I can add them up and get 10. I need it to be a positive 10, so I would need both of those to be positive. Positive 2 and positive 8. So the factoring is done, but I need to solve, which means I need to go all the way to the solution. Technically what happens is that each one of those factors individually gets put equal to 0. So x plus 2, you put it equal to 0. Then x plus 8, you put it equal to 0, and you solve. Well, to solve for this, it's a simple one-step equation. You would have to subtract 2 on both sides, and you end up with x equals 0 minus 2, or negative 2. Same thing happens in the other one, except this time you're subtracting 8. So you end up with x equals negative 8. The answer turns out to be the opposite of what it is in here. So if in the parentheses it's x plus 2, you get negative 2. X plus 8, you get negative 8. If it was something like x minus 9, you would get positive 9, so on and so forth. So the next one, x and x. Numbers that multiply to make 4 can give me a 5, or 1 and 4. To be negative 5, they would both have to be negative, which means that the answer is the opposite. X equals positive 1, x equals positive 4. Those are the 2 places on the x-axis that it will hit. Next one, parentheses, x and x. Numbers that multiply to make 27 and can give me a 6 would be 3 and 9. I need it to be a positive 6, so I need this to be positive 9 and this to be negative 3. Take the opposite of each one of these, x equals positive 3, x equals negative 9, where it will hit the x-axis. Next one's kind of tricky because you don't see a number for b in front of the x. If you don't see a number there, remember it's always understood to be a 1, so technically that's a negative 1, right? This is also a 1. 1x squared minus 1x minus 30. So 2 parentheses, x and x, 2 numbers that multiply to make 30, and can give me a 1, would be 5 and 6. 5 times 6 is 30, and 6 minus 5 would make a 1. It's a negative 1, so I need to make sure that the 6 is negative and the 5 is positive for that to happen. The answers turn out to be the opposite of that. X equals negative 5, x equals positive 6. Number 5, a little trickier because we have a leading coefficient. What we want to see is that if every term can be divided by that number, we just need one extra step, and it can. Every number can be divided by 5, so I'm going to factor 5 out. 5 times what would make 5x squared? X squared. 5 times what would make a 20x? 4x. 5 times what would make a 20? A positive 4. Now the inside trinomial no longer has a number in front of the x. That 5 has now been moved outside the parentheses. So I'm going to keep that for the moment. There's my x and x. 2 numbers that multiply to make 4 and add to make 4 are 2 and 2. They both have to be positive. I can disregard this number in front here and just take the opposite of each one of these. Positive 2 is negative 2. X equals negative 2. And I'm going to stop right there because the second binomial happens to be exactly the same thing. It's not as if I would get a different answer for this one, so I just end up with one solution this time. There's only one place this parabola hits the x-axis, and that's at negative 2. Number 6, we need to make sure it's equal to 0 at the beginning. So we're going to start by adding 14 to both sides, so we get that. Now that everything's on one side equal to 0, a, b, and c, we can now factor. X times x would make x squared. What can make 14 and give us a 9? That would be 2 times 7. It's a negative 9, so I need both to be negative. Take the opposite of what's in here. I get x equals positive 2 and x equals positive 7. Quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. When you look at a quadratic trinomial, a, b, and c are the numbers as follows. A is the number that's in front of x squared, which in this case is 3. B is the number in front of x, which in this case is a negative 6. And c is the number without an x, which in this case is negative 24. Our job will now be to plug it into this formula and do the math and simplify. So I'm going to get negative, I'm going to open up parentheses here. Okay. I'm going to look here, negative 6 goes in that box. Negative 6 also goes here, remember, because negative 6 is b, and the formula calls for b here, as well as b here. Then it's minus 4ac, ac. I need to put a in here and c in here. Well, a is 3 and c is negative 24. So 3, negative 24. Down at the bottom, a is 3. So this ends up being a positive 6 on the outside, plus or minus the square root of. Negative 6 to the second power is 36. Here we're going to get a very large number. It's negative 4 times 3 times negative 24, which would be 24 times 12. Just doing some calculations here. And I get 288 plus 288 all over 6. 36 plus 288 is 324. The square root of 324, if you typed it on a calculator, happens to be 18. And now I'm going to split this into two separate equations. 6 plus 18 divided by 6 and 6 minus 18 divided by 6. Got to use each one of those symbols. 6 plus 18 divided by 6. 6 minus 18 divided by 6. 6 plus 18 is 24. 24 divided by 6 is 4. One of my answers is x equals 4. The other one, using the minus sign, 6 minus 18 is negative 12. Negative 12 divided by 6 is negative 2. All right. I'm going to leave you to do the last two. I hope that helps. Catch you next class.